Today we are going to talk about the cloud sandbox architecture that I've designed, the underlying scripts that are a part of the infrastructure dashboard community GitHub repo. So let's get into it. So first we'll start here with AWS. Really, the whole goal and design for all of the sandbox architectures is to develop a isolated network, ultimately. So there are some pieces that are going to have to talk to the outside internet. One of them is here we have this public subnet that exists inside this VPC, has that internet gateway. This is where we're going to have our ECS cluster that includes the jump point or gateway container for PRA. It has our Fargate runners for the various different jobs. That's going to be for if we're doing any configuration management using those Ansible runs. It happens here. Same thing's also true for any of our promote runner jobs where we take an image inside of AWS, or I'm sorry, an image that's hosted in one of the other cloud providers, and we run a job inside of AWS Fargate as a container. I've got a published image that's out there, and it will take that virtual hard disk, the VHD, and create an AMI. All very well and good, right? So this is the public facing network. Just below that, we do have a private subnet, and this is where we have EC2 VMs. And down below it here, we have the database subnet. So this is where we have the 3 different RDS database types supported by the dashboard. And over to the right here, we also put in the Kubernetes cluster that we can build. So the whole point of this, it's isolated. Everything is tagged that we create with the dashboard. And there's no ingress into that network. And the same story is true for Azure. Now, mind you, I'm showing you all these different architecture diagrams just to show you that ultimately the design and the philosophy is the same. The end up architecture is going to be slightly different, all because the clouds themselves are different. So here inside of Azure, there's a little bit more stuff here. There's this public facing network that actually is the ACI, the container. This is where we can host actual jump points or gateways, and then for where we actually have tunneling as a requirement, we can deploy an actual Linux VM. And same kind of approach, different subnet. Down below, we've got our VM subnet, a K8S subnet, a database subnet, and a desktop subnet for the VDI capability. All of these are private. Everything runs through the public gateway for any kind of public-facing work that needs to be done. And the containers for Ansible, image promotion, all run through this ACI subnet. Awesome. Last one, but not least, Google. Similar kind of idea. We have the public-facing network that hits this cloud router and cloud net. We could see the traffic here, so the gateways can reach the sandbox VMs. We have tunneling capable to the Cloud SQL environment. So this is where those databases reside. We have a private KE or K8S cluster network here. And again, no ingress, all egress by design, which sets me up really for the first integration focus, which is privileged remote access, right? So all of the cloud providers are going to want to encourage you to use Bastion hosts. The challenge and problem with Bastion hosts is that there is an an ingress to those Bastion hosts, and you're putting a lot of faith in the cloud provider themselves and making sure that those Bastion hosts are patched, that they are hardened and only accessible by you, the user. With BeyondTrust Privileged Remote Access, we take a very different approach with that. There is no ingress. Everything is egress. Everything, right? So we have all the different gateways that exist in the 3 different cloud architectures that I just showed. It's in the green box for all 3 of them. It's all 443 outbound connection. They all phone home to this cloud tenant, or it could be a PRA appliance. And the dashboard is going to build all of the objects using Terraform. Gateways get created, the VMs get created, the databases get created, Kubernetes clusters get created. All of it's done through Terraform. Trying to make this as easily as possible from an infrastructure as code perspective. Well, let's layer in the next BeyondTrust technology, Password Safe. So Password Safe, it is the BeyondTrust vault. And the idea for this is that we are going to leverage the built-in agents for those cloud providers for rotating credentials that exist inside of those cloud platforms. So in the case of AWS, it's the SSM agent. So what I'm actually doing is I'm sending that a command as the functional account, or if we want, we can leverage the resource broker in that particular cloud provider as the managed identity, and then we don't actually need a functional account. And it will send the commands to change the SSH key for the VMs. We can send the commands to the database to change the passwords using that SSM plugin. There will be some development that'll be put in place in order to create custom plugins for the same kind of database functionality in Azure and GCP. But today there is functionality or parity to change SSH keys using the agent that's specific to Azure, which is the WA agent, or the Google Cloud, the G Cloud agent. Similar concept, functions a little bit different, right? Let's see here, run command ARM as the service principal or as the managed identity. Here we're sending a compute.set metadata command, either as the resource broker managed identity or as the service account from Google Cloud. All this to say that we can leverage Terraform for creating all the different objects, all of the different vaulted credentials, and have a cloud native approach to vaulting. The last layer, and this is the newest layer, is Entitle. Now, because all of the resources are private resources, we have to leverage the Kubernetes Entitle agent workflow. And what that buys us is the ability to do a handful of things. We'll see here from the diagram. This allows us to manage access to private resources that could be Azure VMs, GCE instances, private EC2 instances. It can be the databases that exist, RDS, Flexible Server, Cloud SQL. And if it is Postgres or MS SQL, we can actually do ephemeral access or ephemeral accounts, which means we don't have to tie necessarily Entitle into with a vaulted credential in order to provide someone access. We can make that account created on the fly. Which brings me to my next slide. How does this all tie together? So we have the access plane with PRA. Password Safe is going to serve as the credential plane. And then Entitle serves as that just-in-time authorization plane. So we're either creating ephemeral accounts or we're granting ephemeral access to already existing vaulted accounts in Password Safe, and the users can access those private resources using privileged remote access. And the dashboard really just serves as a mechanism to facilitate all of the above from an infrastructure as code perspective, so that the resources don't need to live all the time. They need to live just for while you need them. So let's talk about onboarding using that dashboard. So we do have to have some prereqs in place. We need Docker. The container app is a container that resides inside of Docker. And there's really two approaches that we can take. We do need, for all the sandbox scripts, we are going to need these different prerequisites. So Git, PowerShell 7 if we're running on Windows, AWS, Azure, and the G Cloud CLIs. If we want to run from source, we do need to clone the VM dashboard community GitHub repo. We don't have to. If we don't want to, we can skip the clone piece here and move on to step number 2, which is that we can onboard from Docker Hub, which is this -- hub or -hub if we're running it in PowerShell. And what this actually does is it runs a script. I've pretty much got like the sample Docker compose files. It'll bring up a Postgres database container, the app, and I think the default workers are run right now. I have like 3 container workers that will run, but you can actually scale that up or down if you want. There are 2 different paths for figuring. You can run through the wizard and populate your own credentials, and then run through the setup for any additional features that you want. Or you can run the sandbox scripts and push all of those credentials into the wizard through an API. Once you're satisfied with the sandbox environment and leveraging the dashboard to kind of manage the sandbox environment, tear everything down. So I'm moved on to showing 2 different tabs. Got this on the kind of a split view. On the right-hand side, I have the GitHub repo. We're specifically looking at the onboarding guide. And this walks through kind of the 2 different paths that I had on the slide. On the left-hand side is the Docker Hub. Both of these repositories are public-facing. Pretty easy to stand up and get going. There's a sample compose here. So quite literally, if all you want to do is get this thing running, like pull this image and then randomly create a JWT secret key, run the Docker compose up for this YAML file, and it'll spin up a container. It'll be 2 containers, the application container and the database container. If you want a simpler sandbox approach, where like I build out all of the resources using the sandbox script, we can, you can run them individually. They're available here, right? So if we just run over here, right? Here are the sandbox scripts. You can run them on Windows, you can run them on Linux. Doesn't really matter. There's a prereqs check for each of them so that you make sure that that you've got everything that you need. So that's going to include Docker itself, all the different CLIs, as well as JQ, which allows you to basically look at JSON objects. Okay, so instructions are here. They're over here. Really, the path is yours as far as what you'd like to take. I just want to make sure, spend a lot of time creating all this documentation. And quite simply, when ready, you'll come over and run the actual command here. So you'd see I've got 5 different containers, 3 are workers, 1's a database, and then 1 is the actual app. But all I ran was the script, right? The onboard sh pulls from the Docker hub, runs through. If I've already got a JWT, it doesn't generate a new one, which is great. And the default for worker replicas is 3. This we can change if you want. If you need more, or if you need less. And once that's up, the setup wizard is located localhost at this port. Again, if you don't like that, you definitely can change it. Let's go back here to the dashboard, ignore all of those different pieces. And if you ever need to go back through, because clearly I didn't go through the config wizard, it already was configured. If I ever need to go back here and make changes to any of the values, you can hit the cog wheel and hit reconfigure wizard, and this will take you through that initial config. And essentially all we're wanting to do here is populate all the different values. Some of them are optional. For example, like this whole section. If you want to use Microsoft OAuth, log in with an Entra credential, you very well can. This instance isn't set up for that, but all of these different fields, once they're filled out, you turn on the different toggles for all the different feature flags that we want. Hit save changes, go back to log in, and if you ever need a toggle on different integrations, these essentially serve as like feature flags. Say if I want to turn on Proxmox, for example, just toggle that on, fill out all the different pieces, use token is the recommendation as opposed to password auth, and then point it to the host with the right port and everything, and we'll start seeing that information. Thank you all so much for watching. If there are any questions, comments, concerns about any of the content from this video, please post a comment on the actual video post. I do actually read those and check them out. Happy to share any more information or answer any of those concerns. Thank you. Have a great day.